Hey everybody, today we're going to be looking at log rules. So in earlier this year and in Math 2 and probably a little bit in Math 1, you looked at exponentials a lot. And you came up with certain rules that worked for exponentials. Now, since logs are just inverses of exponentials, then these rules should somehow work for us to work for logs as well. Now, it's not exactly the same way, but it is very similar. So just real quick, let's be reminded of those exponent rules. So when we talk about exponents, we have three big rules: product property, quotient property, and the power rule. Okay, so product property says that if I have b to the m times b to the n, I can combine those and say b to the m plus n. Quotient rule said b to the m divided by b to the n gave me b to the m minus n. And then power rule said b to the m raised to the n gave me b m n. Okay, so those were the three big rules. There were some other ones as well, but those are the three big ones that worked really nicely for us. So again, the goal today is to see, okay, is there a way to convert this into logs? Same with this one, same with this one. Okay, and if there is, then great. And if there isn't, then, well, we did something wrong. Okay, because spoiler alert, there is. So starting out, we need to define some terms. I'm going to define m as b to the x, and I'm going to define n as b to the y. Okay, so if I log both sides of that, because again, the end goal is to get to logs, I want to log both sides by log b, because that's my exponential, it's the base of my exponential, which is going to cancel that out, which is going to leave me with log base b of m equals b. Okay, and then by the same token, log base b of n equals y. Okay, so we're going to be using that pretty significantly today. Okay. So the question is then, I have m and n, we just define them as this, and then using our product rule of exponents, I can say that it is equal to that. So the question comes down to, is there a way to prove this also with what we have? So I'm going to do m and n equals b to the x plus y. That's proven up here. Okay, I'm just skipping the middle step. Okay, well, let's log both sides. Log of log base b of mn equals log base b, big B, of x plus y. Okay, cancels. So log base b of mn is equal to x plus y. Well, I really want everything to be kind of in logs. Oops, I'm so sorry. I wrote it correctly down there. I didn't write it correctly up here. There we go. I really want this in logs. Well, I know what x and y are equal to. Okay, x is equal to log base b of m, y is equal to log base b of n. So let's substitute in. Log base b of m plus log base b of n. Okay, so the product rule of log says that the log of mn is equal to the log base b of m plus the log base b of n. Okay, and that works at both directions. I can combine these or condense or expand these or separate them. Okay, using that same idea, we should be able to do something very, very similar with quotient rule. And what we're going to get is log base b of m minus log base b of n. Okay, again, for that same reason, when I log both sides, it's going to turn into that minus, and then I would substitute back in. So this would be my quotient property of logarithms. If I have a subtraction symbol, basically what that means is it's going to go on the denominator. Okay, and then the last one with the power rule, we're going to end up with n log base b of m. So what happens is you can bring this n, put it over here. If you have an n, you can put it back up with the m. You can move it around. Okay, the reason being is because of the power rule. Okay, so we've got the three big properties: product property, quotient property, power property. Again, the product property says if I have them multiplied, then they could have been added. If I had them divided, then they were subtracted, and then I can always bring this n in front or vice versa. Okay, so knowing that, how does this help us? Why is it useful to combine them when I can just put each one in the calculator individually? Well, depending on what I know and depending on what I'm looking for, and we'll get into this more in the next section, sometimes it's better to have them combined. Sometimes it's better to have them expanded, especially when you're in calculus too. Sometimes it's better to have them all as one because then you're dealing with one versus multiple. But, for example, if I had log base 2 of 3 over 7, I can expand that as log base 2 of 3, log base 2 of 7 minus. And then if I know that log base 2 of 3 is about that and this is about that, I can plug this in. And then head over to my calculator. Because so far, we still don't know how to solve logs of different bases. Okay, you will actually know that by the end of today, but for right now, we don't know how. So I get negative 1.222. Okay, now here, again, not immediately obvious, but I could say log 2 of 3 times 7, which I can split up to log 2 of 3 plus log 2 of 7, which means then I can add these. Okay, that's going to give me 2, carry 1, 9, 3, carry 1, and there we go. Okay. Now for this one, I've got two choices. I could say log base 2 of 7 squared, or I could say log base 2 of 7 times 7. Okay, this one would be done, on the right would be done exactly like this one. Okay, but let's do one that's a little different. So I'd say 2 log base 2 of 7, so I can always bring that out front, right? We can move this down and vice versa. And then I have 2 times 2.807. That's going to give me 5.614. Okay, and if I did it this way, I'd get the same thing. Okay, now the question comes into play, can I do this multiple times? And the answer is yes. Not only that, but I can mix things. Okay, so the goal here with condensed problems is we want to get everything close together. So I can say log 9. I'm going to move this 3 up here first. Anytime you have a coefficient out front, you do want to move that up as an exponent first. So log 2 to the 3rd. Sorry, minus log 3. Okay, and now that I don't have any coefficients, I can just start adding and subtracting these and combining them. So for the first two, since it's addition, it's going to turn into multiplication. And then this last one, subtraction, is just going to turn into division. So anything being subtracted is going to go in the denominator. Okay, and then there's my answer. Okay, now I could simplify that down, but I'm just going to leave it like that. And for your homework today, I want you to leave it in that form. Don't keep simplifying it. Okay. Okay, so that's the first chunk of what you need to be able to do today. Real quick, just some of these, expanding this one, what it's asking you to do here is we want to separate these first. So log base 6 of 3 plus log base 6 of x to the fourth. Okay, I can bring that 4 down and put it here. Here I would have ln of 5. Okay, now this 12 and this x are in the bottom, so they're going to get a minus ln of 12 minus ln of x. Okay, condensing here, log of x over 9. Okay, the 9 is going in the denominator because of the subtraction. Okay, I want to move this 3 up here first and then start combining. So we have 4 times 3 cubed minus 12. Or sorry, divided by 12. Okay, last thing we need to remember on these is we do have to have the same base. So something to note is if you had log base 3 of x plus log base 4 of y, I cannot combine these. They are not the same base. Okay, so what I would like you to do now is pause the video. On your, or not quite yet, obviously, on your assignment, I want you to do the odd problems in the first 2 sections. Okay, just the first 2 sections. I believe that's through 29, I believe. Okay. Yes, so 29. So 1 to 29 odds. Okay. Work on those. The answer key should be with the assignment as well. Okay. Since I'm giving you the answer key, I should see some work. Okay. So especially if you have like this step, make sure you're showing that. Okay. Show what's going on. Okay. And then when you're done with that, come back or resume the video. And I got one more quick thing to show you. So go ahead and pause now. Okay, last thing we need to look at is change of base. So in the last unit, when we had something like this, okay, we tried to set it equal to x and exponentiate both sides, and it worked nicely for us. But what about this? We don't have anything nice that tells me, hey, x should be this. If this was a 4, right, then I could solve that. But since it's a 3, I can't really solve that. So the question then comes into play, how do I solve these? Well, we can use what we call change of base. So if I have log base c of a equals, we can separate these by saying log of a over log of c. Okay, now it's going to be always the biggest number over the smallest number. And when I mean big, I mean actually taller. Okay, not just like 3 is bigger than 2, actually bigger. Okay, so the base is always going to go on the bottom, and then what you're taking the log of is always going to go in the numerator. So for example, log base 3 of 8. Okay, I would say log of 8 over log of 3. Okay, now please make sure you do close off your parentheses nicely here, otherwise you could have issues. So I can say log of 8, close parentheses, divided by log of 3. Okay, and that's going to give me about 1.82 or 1.893. Okay, now it doesn't matter if you use ln. ln would also work just as long as you use ln for both of them. It actually doesn't matter which base. It's just we have 2 very specific buttons on our calculator, so those are the ones we're going to want to use. So this is approximately 1.893. Okay. Now again, let me find one. Let me change this a little bit. Instead of this one, let's do log base 5 of 3. Okay, now again, I know 5 is bigger than 3 on the number line, but we want to put the what we're taking the log of in the top, so log 3, and then the base in the bottom, the little number in the bottom. Okay, so now you should be able to do the last page. Okay, I know it's a lot of problems, but again, like these really don't take too long. Most students today in class got done in about 30 minutes, maybe less. Okay, so you should be able to get these done. Again, we're just doing the odds today. Okay, so please make sure you work on those and for homework, and then I will see you guys next time.